Okay, next thing we're going to look at is geometry of linear transformations of a plane. So these are all going to be transformations from R2 to R2. And so they're going to have, a 2 by 2 matrix, A, B, C, D. And depending on the numbers in that matrix, different things will happen. So certain linear transformations will reflect things across lines. We'll also have transformations that expand and contract things. Shears, we'll talk about that later. And things that rotate the plane around the origin. One thing common to all of these is that they all have a 2 by 2 matrix, and the determinant of the matrix tells us two things. The absolute value tells the ratio of the area of an image to the area of the pre-image. So, for instance, if you applied a linear transformation to a square like that, if the determinant was, let's say the area of this is 1. If you used a matrix with the determinant of, say, -2, what that would do is the image of this square would double in size, and the negative says that the orientation will change. And what that means is, instead of being like the original shape, it would be some version of the mirror image. So we'll look at that more in just a minute. And if the determinant winds up being 0, what that tells you is everything in the plane gets smashed into a line, or possibly just smashed into all of it into the origin. So let's first talk about reflections. A reflection reflects the entire plane across a line that goes through the origin. And I've got several examples here. We've got this right here would reflect things across the y-axis, this across the x-axis, and this would reflect things across y equals x. And I think you can see that pretty easily. If you were to take this and multiply it by xy, well, if you look at what happens when you do the matrix multiplication, you get -x y. So that's going to take a point that's over here, and it's going to map it over to here. This next one, if you multiply this by xy, I probably should have put more room in here. If you multiply that out, you get, let's see, x and then -y. So that's going to flip things across the x-axis. And then this one flips things across the line y equals x. Because if you look at that, it just swaps the places of y and x. So those are the three simplest reflection matrices. This thing down here on the end, though, this is for reflecting about any line y equals mx. And okay, this thing on the end, this is for reflecting across the line y equals mx. And one thing about all of these is the determinant is always -1. Now, it's easy to see that on these first three. Determinant of this is -1. Determinant of this is -1. This would be 0, -1. This over here, if you were to take this and work it out algebraically, you can see that the determinant is always going to be -1. And that makes good sense, because if you take something and just reflect it across the plane, across somewhere, its size doesn't change, but it does give you the mirror image. So the mirror image tells you the negative, and the 1 tells you that the size does not change.